I will speak in English. And good evening, everyone. Nice to see you all. And it's great to be here to make this presentation together, right? So I was asked to give this presentation on how to write a paper to an academic, how to write a journal publication. So when we do research, it's very important that we communicate our findings, our ideas, the knowledge that we develop. This is one of the key functions of doing research. Why this is important? Because if we communicate our ideas to others, then others can learn from our own understanding, the hard work that we've done, and our understandings that we develop. Others can learn from that, and they can build on that knowledge. So one way to communicate these ideas, one good way to communicate these ideas is to write it down in a research article and publish it in a journal. Of course, you can publish it in conferences. Publishing is important. So here I was asked to talk to you all about how to go about writing a research article. So this is the outline of the talk. So I will talk about some general rules when it comes to writing a paper, some general rules that perhaps we need to be aware of. I will talk about the aesthetics of the paper and the first impressions of someone who is going to read your paper. Aesthetics is how your paper looks like. So aesthetics of the paper and because your paper, when you write it to somebody else. So somebody else is going to read it. So somebody, when you look at the paper, will have some first impressions. So I will talk about that as well. I will talk about some software tools that are required for writing a paper, some tools that you need to be familiar with. I will talk about identifying an important problem to solve, because we need to identify an important problem and then solve it. And only when we solve an important problem that we can write a paper about it, and it will be useful for others. And once you solve the problem, I will talk about getting ready to write, because once you've done your work, once you've done your research, you identify the problem, you solve the problem, then you're ready to write a paper. So I will talk about getting ready to write a paper. And then I will also talk about some case studies, some examples from my own research. So some examples, I'll give you some examples. So firstly, some general rules. So Albert Einstein, one of the greatest scientists the world has seen, once said, everything should be as simple as it can be, but not simpler. So I highlighted the part, as simple as it can be, but not simpler. So what do you think Einstein meant by this quote? This is a very famous quote. Everything should be as simple as it can be, but not simpler. So maybe Einstein meant it is desirable to keep even the complex theories as simple as they can be, without losing the meaning of those theories. But some theories cannot be reduced to something simpler, as they become inaccurate. So all theories, you want to simplify. You want to simplify it as much as you can. But if you continue to simplify it any further, it might become inaccurate. So there is a limit. So that's perhaps what Einstein meant by saying everything should be as simple as it can be, but not simpler. So you want to make your understandings, the theories that you develop, as simple as it can be, but not simpler. Because if you make it simpler, then you would lose meaning of the theory and it becomes inaccurate. And need to consider irreducible basic elements without having to lose meaning. So when we have something complex, we reduce it to some basic elements. We keep reducing it to some basic elements. But we reduce it until we cannot reduce any further. Because if you do, how do we know that we cannot reduce any further? Because if you do, then you lose meaning. Right? So the second sentence is essentially saying the same thing as the first sentence. And the best theory is the simplest one that still explains observations. So we want the theories to be simple, as it can be, but not simple. And the best theory is the simplest one that can explain the observations. So I think perhaps this is what the greatest scientist Albert Einstein perhaps meant when he said everything should be as simple as it can be, but not simpler. So continuing on with some general rules, those are the three that we saw. The fourth one, so when we write our papers, so these are some general rules. Sentences need to be clear, concise, and accurate. It has to be very clear. So every time when we write a paper, we write a sentence, we need to spend time, make sure that every sentence we write is clear, it conveys the meaning that you intend to convey, it's concise, in other words, you write it in the shortest possible way, it's concise, and it has to be accurate. It has to be accurate. So every sentence when you write, it has to be clear, concise, and accurate. And there should be no repetition. You must not say the same thing over and over again. Because if you say the same thing twice, it'll confuse the reader, right? It'll confuse the reader because you want to say something once and it has to be accurate. It has to convey the meaning that you intend to convey. And the sixth point is there need to be order or structure enabling to see connection and logical flow of arguments. Because when you write a paper, you are presenting a technical argument. So there has to be some structure and there has to be logical flow of your arguments. Your arguments need to flow logically. Yeah? So I think these are some general rules to keep in mind when we're writing a paper. Now, with regard to aesthetics and first impressions is kind of what you feel when you see somebody for the first time. And someone once said, first impressions last. Right? So first impressions are very important. So when you write a paper, right, how the paper looks is very important. The first impression. So the paper needs to look absolutely beautiful. It needs to be really good. You need to spend a lot of time to make sure the paper really looks good. Written articles need to be aesthetically pleasing. And to get an idea, you can read already published articles to get an idea. You can see in some journals, some good journals, right? Have a look at how the paper is written. That paper is not formatted by anybody else. It's actually formatted by the author. So it's up to you to make it look really beautiful, to format it really well. So the first impressions are very, very important. Yeah? And when you write a paper, you need to carefully consider the graphs, tables, and figures to be included and present those for maximum impact. So the graphs, the tables, the figures that go into a paper, right? You need to carefully think about it. What is the information that you're going to put in there, right? And it has to be for maximum impact. It has to convey the message you want to convey. Yeah. So this needs a careful thought, careful consideration. Now, somebody when you send a paper to a reviewer might take a quick glance at the paper. He might not read the entire paper entirely at the beginning. Might take a very quick glance. So a reviewer might just look at the look at the title, might look at the abstract, read the conclusion, might just glance over the paper, see what sort of equations are there, what kind of tables are there, what kind of figures are there, and a quick glance should actually convey the message, like should convey some information. So it shouldn't confuse the reader. A quick glance still should give some message, should tell you what this paper is about. So if you've written a paper and then you quickly look at it, right? And if it doesn't give any information, then perhaps that's not very good. It needs to convey the information. That's where you need to think about writing the abstract well, writing the conclusion well, considering what graphs, tables, and figures you're going to put in, because when the reader look at it, that it should tell without having to read, because reading is a difficult task. It's going to take time, and the reviewers are doing this for free. They're not paid for it, right? So they're going to take a quick glance, and the paper needs to look good, and this also has to do something with the first impressions, because your first impressions of the reviewer might determine if the paper gets accepted or not. It might, right? So we need to pay careful attention to these things even when you've written the paper. And it should be easy to find information in the paper, right? So I mean, when we got a paper, we know it's got lots of information in it, and reading it is going to take time. It might be difficult also, especially technical papers. So it should be easy to find the information. It has to be structured so that the information is there for the reader to take. It should be easy. The information shouldn't be hidden somewhere in the text or in the paper. It should be easy to find the information. So, what are some of the tools for writing a paper? What are some of the word processing and illustrations? There are a number of packages that are available. For example, LaTeX. LaTeX is a package that I use for word processing, and many of the journals actually use LaTeX for their publication. So I would say if you're a student, right, using Microsoft Word is perhaps easy, but it might be better for you to spend a bit of time at the beginning to learn about LaTeX, how to do word processing in LaTeX. Because when you do word processing in LaTeX, the documents look much better, much nicer, and it looks technical. So I would recommend that you you spend a bit of time actually learning about LaTeX. And learning about LaTeX is not difficult. There is a lot of resources on the internet. So a lot of tutorials, a lot of resources. So it's extremely easy, right? So in Baidu, if you type LaTeX, there a lot of this information will be available, a lot of tutorials, and you can learn about it. And I use a package called Text Studio. That's like the front end for the LaTeX, and I find that's quite useful. I mean, you might have your own preferred text editor. That's fine. I'm just listing it down, some of the packages that you can use. For doing graphs, you can use, of course, something like Excel for doing bar charts and pie graphs and whatnot. Lix is another alternative to LaTeX, right? It's also something closely related to LaTeX. So Lix is a possibility. Word can, of course, most of you will be familiar with Word, but I would recommend using LaTeX. There is the math type is another package that will allow you to write equations. Image Magic, again a package that is available on the net. You could use that to edit images. You can change, you can edit images using that. And another package that I use quite widely is Tix. Now Tix is a drawing package, right? But you use code, like you use kind of LaTeX code to draw figures using Tix. Again, it might look a bit difficult to use Tix at the beginning, but it's worthwhile to learn that. Because if you learn that, if you learn Tix, it links very, very closely with LaTeX, And the figures look absolutely beautiful when you do it in ticks. You won't actually draw it. You would write some code to actually draw the figures you want to draw, right? I would recommend that you learn about this. So before even writing a paper, it's better to be familiar with these kind of software tools. So when you want to draw figures, when you want to plot some curves, you know what packages to use. So you can focus all your energy on presenting your idea when you try to write your paper, so you don't have other obstacles to overcome. So I would practice these things. And Visio is another package that you can use to draw curves, and there are other packages like graphics and all that which you can use. So with the word processing packages and also in writing, sentences need to be grammatically correct and without any spelling errors, right? So it is important for us to choose a word processing package that has spelling and grammar correction capability. Because when we write, we could always make a mistake in spelling, right? So the word processing package needs to have the spelling and grammar correction capability, so it can be fixed. Because the paper won't look good if it has any errors. In fact, the paper should not have any errors at all. It should be perfect in terms of no spelling error, no grammatical error. So you need to spend a lot of time to make sure everything is perfect. Yeah, it has to be like that. And LaTeX and MS Word are some widely used word processing packages because there are a lot of templates available. You can download these templates from the internet, and people do use them. But as I said, my preference and recommendation would be to use something like LaTeX. Now, I was talking about the importance of doing your graphics nicely. Now, this is a graphic that we used, put in our paper. Now, to do something like that, we spent quite a lot of time. This was done in Visio, right? So we spent probably a day or half a day to a day to make a beautiful picture like that. And that picture then goes into the paper. So I'm just trying to highlight how important it is to make the graphics really look beautiful. Yeah. So this was done using Visio. Now this is something that I did using Tix. I said Tix also a package that you can do graphics. Again, it looks really nice when you use a package like Tix. You can see the equations, the symbols. They all written in LaTeX, and you can do that when you do it in Tix, right? So it's important to spend quite a lot of time to make sure that the documents look good. Now, what are the other things that you might want to be familiar with? Well, you perhaps want to be familiar with some symbolic calculators and numerical computing packages, such as Mathematica, MATLAB, and if you're doing some circuit design, maybe PSpice. So some familiarity with these packages will also help you in writing a paper, right? And Mathematica, MATLAB, you can use Mathematica and or MATLAB, right, to develop and verify theories. So when you come up with a theory, you can verify it. And you can actually use MATLAB and Mathematica to aid developing the theory as well, because you can try things in MATLAB and Mathematica. So again, for you to write a paper, you need to have some understanding of packages like this. So I would spend time, a little bit of time, to try and get familiar with this. You can also use Mathematica or MATLAB to perform simulation studies and plot graphs. So you can do graphs. Now, MATLAB can give good graphs, but we don't even use the graphs produced by MATLAB. There is another package which you can download from the internet where you can convert the MATLAB graphs to ticks. So MATLAB to ticks. So again, if you do a search on the internet, MATLAB graphs to ticks, there will be some code that you can download, and it will take the MATLAB graph and it will convert it to ticks, and the graph in pigs looks much better than what you can generate from MATLAB. I mean, MATLAB graphs are good, but pigs graphs are better. So why not make it better? Yeah. So all these tips, I think, will be important. Now we know that Mathematica can perform symbolic calculations. So if you want to, simplify some complex, mathematical expressions, you can use a package like Mathematica to do that, right? And MATLAB is particularly good for numeric calculations. So if you're dealing with a lot of numbers, MATLAB will be quite good. And both Mathematica and MATLAB have built-in functions. People have already written functions and available on the net which you can download, so you don't have to write it yourself. You can utilize some of these functions that other people have used and made it available on the internet. You can download and use them. So these are two packages I would recommend that you are extremely familiar with, which will help you to write a paper. I think for circuit design in Power, packages like PSpice will also be extremely useful. All right. Now, in writing a paper, identifying an important problem to solve is important, right? So that cartoon on the left, we see a teacher and a student, right? There is a question to be answered, a problem to be solved, right? And the teacher says to the student, you have to solve the problem yourself. You can't call tech support to do that, right? So I guess if you're doing a PhD, right, or you're an academic doing some research, generally you will have a problem and you'll have to solve the problem yourself. You have to do a lot of thinking to do that. And the picture on the right says, well, whether you have a problem or not to worry. Don't worry. Yeah. So it says, do you have a problem in life? Well, if you go to the right, if it says no, then you don't worry about it. Do you have a problem in life? If the answer is yes, can you do something about it? If the answer is no, you can't do anything about your problem, then you don't worry about it because there's nothing you can do about it. But if you can do something about it, then you don't worry either. So either way, whether you have a problem or not, just don't worry, is what that picture is telling, right? But anyway, for our research, we need to identify an important problem to solve. Only when we solve an important problem, then we can write about it, right? And others will learn from that. Yeah. Okay. So what are the steps to identifying an important problem to solve? So we need to identify. So how do we go about identifying an important problem? Yeah. How do we do that? We need to read widely. We need to read a lot. We need to read relevant scientific journals, right? We need to read widely. We need to read general information on the internet about some problems that need to be solved. Yeah, we need to read widely. We need to understand our strengths and interests. We need to understand what we are good at. Because if we do something that we are good at, we have more chance of succeeding. Right? We have more chance of succeeding. Right? We need to attend seminars, workshops, and conferences so that we can hear what other people have to say, right? And we can learn from it. Right? So it's important to attend seminars, workshops, conferences, like even this one. Right? So we can just hear about what others have to say, and we can have our own opinion about it. Yeah. Okay. We need to be part of a relevant research community because there are different research communities, right? If you are interested in power electronics, there will be a research community for power electronics. If you are interested in power systems, there will be a research community for that. If you are interested in control systems, there will be a research community for that. So it will be even in an academic institution like this, even within electrical engineering, there will be various sub-branches. And it will be important to be part of that community so that we can exchange some ideas, right? And if you have problems, you can just ask the other colleagues if they could, shed some light to give some valuable information. So it is important to be part of a relevant research community. And the relevant research community need not be local, need not exist within this institution. It could be other institutions in China. It could be institutions overseas, like UWA, right? You know my details, you can communicate, right? And it's also important to collaborate with others, yeah? Because when you collaborate with others, the others are also smart people. You are not the only smart person, so others are also smart. So it is important to collaborate with others, and then you can exchange ideas, right? So all these will help you to identify an important problem. Because only when we identify an important problem, we can solve it and we can write about it. Yeah? All right, so I'm going to give you some examples, couple of examples on identifying an important problem. Couple of examples, right? So this picture here shows the energy sources that we have relied in the past, right? So on the horizontal axis we have time, right? So we have years 1850 to year 2000, right? And on the vertical axis we have the percentage, right? So we can see before 1850 or thereabouts, right? In the early part of our civilization, people have relied on wood to serve our energy needs, right? To keep our house warm, to do cooking, right? To serve our energy needs, people have relied on wood, right? In the mid-1800s, right? With the invention of the steam engine was invented around about in the mid-1800s, right? People have relied on coal to serve our energy needs, because that's the time the steam engine was invented. The mid-1800s, steam engine was invented, right? So when during the first industrial revolution, steam engine was invented, it was used for producing clothing, right? And to power the steam engine, coal served as an energy source, right? And also the first steam engine, Thomas Edison, right? Somewhere in the 1800s, right? Connected the first steam engine to an electric motor to produce electricity. And he supplied electricity to New York City, right? And that's the first known electrical utility that we know of, right? So since then, we have relied on coal, right? We have relied a lot on coal to generate electricity from that point onwards. In fact, according to the Bloomberg 2018 report, right, 70% of electricity is generated using fossil-based fossil fuels. Only 30% comes from renewable energy, right? Yeah, and vast amount of our energy is coming from coal, right? Okay. So now in the mid 1900s, right, the internal combustion engine was invented, internal combustion engine, and we have relied on oil and natural gas as energy sources as well, around about 1950, right? With the invention of the internal combustion engine, we have relied on oil and also natural gas. So if you look at year 2000, right, we rely about 10% on wood to serve our energy needs. We rely about 25% on coal, about 30% on oil, 20% of our energy needs are met by natural gas, right? And the rest comes from hydro and nuclear, right? That's the energy mix. That's the energy mix in year 2000. But now and into the future, this energy landscape is changing. There is a huge focus on renewable energy. And this is driven by the depletion of fossil fuels and the need to reduce carbon, right? Carbon emissions. So there is a huge focus on renewable energy. According to Bloomberg, that 70-30 percentage, 70% fossil fuels, 30% renewable, is going to change. It's going to be other way around by 2050. It's going to be 70-30, 70 renewables, 30 fossil fuels. So there is going to be a huge uptake of renewable energy. So renewable energy is going to be a very important topic into the future. And there are many problems to solve in this space, right? So if you read widely, this is general information. This is not technical information, right? So if you read widely, you will be able to identify an important area to work on. I'm not saying this is the only area to work on. I'm just giving it as an example, right? If you read widely, you need to read widely. See what is happening in the world, right? Because like in 2016, right, China introduced 225 gigawatts of renewable energy into the energy mix, renewable energy. And China puts in a lot of investment into developing new technologies for renewable energy. In fact, 60% of the solar panels in the world, right, are produced in China, right? Is produced in China. So there is a lot of activity. So we need to read widely and understand where the world is heading, what are some of the important problems to solve, and then go deep into some of the technical issues in these areas, and then solve it, right? I'm just giving you an example. Yeah. So this is exactly what is happening in Australia. There is a lot of activity. This is what happened in 2017. China is not the only country that is interested in renewable energy. India is interested in renewable energy. India has a population slightly less than China. 25% of the world energy needs will come from India, and India embraces renewable energy. So there will be a lot of activity in the renewable energy space from India, right? In Australia, this is the situation, right? A lot of countries in Europe and even Africa are quite active, committed for renewable energy, right? In 2017, there was 2.2 billion investment in Queensland, right? 2.1 billion investment in New South Wales, 1.3 billion in Victoria. These are the different states in Australia, right? I come from Western Australia on the left, right? And in total, right, 3.5 gigawatts of renewable energy was either started or constructed in 2017 in Australia, right? There was an investment of about 7.5 billion, and that has created 4,100 jobs. So when you identify an important area, of course, then there is a lot of activity, a lot of problems to solve, and also there will be a lot of investment from the government and private sector. There will also be lots of jobs, right? Lots of jobs. So you need to read widely. So what I'm stating here is not technical information, it's general information that you can read about. But I think it's important to read about this general information so that we can identify an important problem, important area to work in, right? So this picture simply says what Australia is planning to do, right? On the horizontal, you have the different technologies, the coal, closed cycle gas technology, open cycle gas technology, other gas technologies, solar, wind, etc. The different ways, different technologies to actually produce electricity, right? And the vertical axis tells the generation capacity, how much generation capacity. The orange is telling the existing or less announced withdrawals. This is what Australia is planning to withdraw. So you can see Australia is planning to withdraw a lot of coal power stations. It's intending to retire a lot of coal power stations. And the blue is the proposed. So when it retires the coal power station, we need to replace with something else. So Australia is planning to replace those retiring coal power stations with solar and wind generation, wind power stations. Right? Yeah. So that's the plan. Just giving you an example of the activity. Right. So now, if the world is actually going to introduce more and more renewable energy, right? This picture here shows how the power grid looks like today and how it will look like in the future, right? So in the top row you can see on the left hand side, top left, you can see the demand, right? Because we have customers, right? We have a need to consume electricity, right? We have a need. So there will be a demand from customers for electricity. There will be some demand. And this demand will be met by some production on the right, top right, right? And on the top right, you can see the production is primarily based on coal power stations and gas-fired power stations, right? So you can see a lot of smoke coming up, right? Coal-fired power stations and gas power stations. Now, with those conventional generation sources, right, we can control the amount of fuel we burn, right? We can control the amount of gas we burn. We can control the amount of coal we burn, right? So we can control the generation, because if you burn more fuel, you can produce more electricity. If you burn less, you produce less, right? So at the moment, the demand, because supply and demand has to be matched at all times, right? Customers will have a demand, and the generation sources will produce that demand. So at the moment, supply and demand is matched on the generation side, on the right, by burning more fuel or less fuel, by producing more electricity or less electricity. Yeah. So that's the situation right now. So you can see all the ancillary services, all the support services are on the right hand side, on the generation side, because we are going to increase or decrease the generation based on customer demand. So customers will increase or decrease their demand at will. They won't care, like we don't care. We will turn on this light, turn off this light. Yeah? But the power station will have to follow based on our demand. If we switch off the light, they have to decrease. If we turn on the light, they have to increase. So all the support services on the right, and we can do that because we can control the amount of fuel we burn. But the situation in the future, if there is going to be more renewable in the grid, in the mix, is going to be different. Because with renewable energy, the generation is tied to weather. We cannot control. We cannot control the amount of generation. Because when the sun shines, we will have electricity from solar. When there is wind, we will have electricity from wind farms. So the generation is not controlled. We lose the ability to control the generation. So the supply and demand has to be matched on the demand side on the left. So if the supply is less, we will have to turn off some of the load. If the supply is more, we can turn on all our loads and charge some batteries. Yeah? So all the support services, the ancillary services, has to reside on the demand side. Right? So this will be the situation if the world heads in this direction of embracing renewable energy, and we know that's the way it's headed. Right? Yeah. So this is all about understanding what is happening outside, reading widely, and then selecting a topic to work on. Right? Selecting a topic to work on. So here we see a customer, right? Now, with customers, we know that we have to either increase or decrease the load to balance the supply and demand. So if we are going to do this, if we are going to increase and decrease the loads, we need to identify in a customer what are switchable loads and what are critical loads. We need to identify this. We need to categorize. So what are switchable loads? Loads that you can turn on and off without interrupting the process. So if we can turn on and off without interrupting the process, that's not a problem. We can turn them on and off at will. Yeah? Critical loads, non-switchable loads, or critical loads are loads which are essential for uninterrupted operation of the process. So critical loads need to be kept on all the time, because if you turn them off, then we have a problem. We have to interrupt the process. So those critical loads cannot be touched. They have to remain on all the time. Only the switchable loads that can be turned on and off without interrupting the process, that we can turn on and off to balance the supply and demand of power, right? So here shows a connection, how a customer, which is a cement plant, right? That's a customer, how the customer is connected to the grid. We can see the customer is connected to the grid. Customer also may have some renewable energy source locally, so solar can produce some power required for the customer, and the customer can also have some energy source locally. So the energy storage system is a battery, right? So that is also connected to the customer, right? So this is how a customer may be connected, right? And this is how the customer may be connected. And this figure here shows the load profile for the customer. The black curve is the power curve, the power requirement of the customer. So the power requirement of the customer, the horizontal axis is the time, right? Vertical axis is the power. The black line is the power requirement of the customer. The power requirement of the customer is changing over time. It's not constant, right? It's changing over time. Now the red dotted line, remember the customer has switchable loads that you can turn off and on, and they have critical loads which you can't turn off. So if the customer turns off all the critical loads, the power requirement will drop down to that red dotted line. So you turn off all the switchable loads which are non-critical, the power requirement drops down to the red dotted line, right? And on top of that, if we use the battery, right, as an energy source, then some of the energy requirement for that red dotted line can be fulfilled by the battery, so the energy from the grid can drop down to the green dotted line. Right? Energy from the grid can be to the green dotted line if we use the battery as an energy source. Now, if we, from the black line, if we turn on all the critical loads, if we turn it on, all the critical loads, the power requirement from the customer will be the blue dotted line, right? And if we decide to charge the battery, then the battery will act as a load, so the load will increase, and the power from the grid will be represented by the green dotted line, right? So from the black line, in the upward direction, we can go to the green dotted line, we can increase the load. From the black line, we can also decrease the load down to the green dotted line in the opposite direction, right? So that brown arrows tells you the power regulation that is possible by this customer, because this customer can increase or decrease the load by that much, given by the brown vertical line, right? So that is the amount of regulation. So why would the customer actually regulate? Why would the customer actually do this? By providing this regulation, the customer will be able to have some economic benefits. The grid operator will pay the customer for doing this, because this has to be done. Supply and demand needs to be matched, and it is the customers who can do that. So for providing this regulation, right, the customers will get paid, right? So if you look at this customer now, customers have two ways to make money. One way to make money is to provide the regulation. Yeah. The other way to make money is to actually produce a lot of goods by increasing the base power. The black line represents the base power. If you consume more power, you will probably produce more goods and make profit, right? So by increasing the base power, you can make money by producing more goods, right? By providing regulation, you can make money. So the customers have two ways of making money, right? So to maximize, you need to choose the correct proportion. How much to produce, how much to provide regulation. So it becomes an optimization problem. So we could say, based on the electricity prices, right, during the day, based on the regulation offers during the day, right, customers now have two ways to make money, two avenues, right? By increasing the base power, produce more goods to generate profit, or provide regulation and to generate profit that way. But you need to decide how much regulation you're going to produce, how much base power you're going to use. Yeah? So it becomes an optimization problem. So we can write down a profit function and maximize the profit and determine how much base power that we should be using at a given time and how much regulation that we should be providing to maximize the profit. So that is some kind of a problem that we can solve. Yeah? I'm just going to, so I'm basically trying to illustrate to you, right, by reading widely, understanding a problem that the world has, right, in general, then looking more detailed into technical, you can solve some problem, and then you can report your findings in a journal, right? You can report your findings in a journal, right? Yeah. How much time do I have? What time do I go till?
1 hour.
1 hour. What time did we start?
4:30.
4:30, 4:40, is it? Oh, okay. So I think we've taken quite a bit of time. So I think I'm going to jump ahead. I'm going to jump ahead, right? So now that you solve an important problem, I had some other couple of examples, but I don't think I have time to go through all that, right? But I just want to give you a general feel to how to go about writing a paper. Now that you solve, let's say you identified a problem, right? And you have solved this problem, right? You solved the problem. Now you need to write it because you need to tell others your solution. Yeah? So you need to get ready to write. So when you are ready to write, we need to think about the market, who we are writing to. We need to think about some preliminary questions, and we need to think about the structure of the paper, right? So the market is who your readers are going to be. Preliminary questions to consider. We need to think about some questions, and we need to structure the paper when we are ready to write, right? So firstly, let's look at the market. The market is who your readers are. Suppose you are writing a thesis or project report, right? If you're writing a thesis, PhD thesis or a project report, then who is going to read your report are your supervisors and examiners. And why they will read it? So that they can judge, mark, and rank your project. So we need to understand who we are writing to and how they are going to judge, what they are going to do with it. Yeah? If you are writing a paper, for publication, you are writing to the scientific community, to other academics in other universities or research institutions. And how are they going to use it? They are going to judge on originality. Is it new? Is it something new that you are saying? They are going to judge on quality of the paper, quality of the information, technical arguments that you are presenting, sustainability, suitability to publish in a particular journal, right? To extract information and to learn from that. So they want to read, they want to know about the originality, they want to learn something from that, right? So we need to understand this is what they're looking at. So that we need, as a writer, we need to provide that, right? Now, research, if it's a research proposal, then who will read it? The funding body and its referees, right? Funding body and its referees. Why they will, how they will use it to judge the aims, quality, what you promise, and appropriateness of the work, right? And the relevance. If it's a popular article you're writing, you're probably the people who are reading it are intelligent but uninformed. So you're writing a popular article into some paper or magazine, right? Intelligent people you're writing to but uninformed public, right? How will they use it? Well, they want to be introduced into a new field, or they want to be entertained. They want to enjoy the reading. So we need to understand who we are writing, what is our market, who we are writing, and how are they going to use it. Because then we know how to write it. Yeah. So what are some of the preliminary questions that we need to consider? We need to think about what is the topic of the paper. why is this topic important? We need to think about it. Why is it important? What is the topic? Why is it important? This is, before writing, we need to think about these things. How could I formulate the research question? Because you will be solving a problem, but how do you formulate the problem? How do you state the problem? Because you need to state the problem. Yeah? And what are my results? You need to think about what are the results that you have, that you're going to put in the paper, right? And you also need to think about what is your major finding. What is the major finding you're going to write in this paper? What is the major finding? Yeah? So you need to think about, before even writing the paper, we need to think about it. Right. So once you thought about it, then we need to structure the paper. Of course, the paper is going to have a title. We need to give a title, right? Because title is important because it may influence the impact of your work and the number of readers that it will attract. We need to have the correct title, right? Title is important, right? And make sure that the title is a good summary of your work and that it addresses the right audience. So the title has to be a good summary of your work, right? So for example, that's the title that I've given, on the existence and design of functional observers. So it's very clear what the paper is about. It's very clear, right? And it has to be a summary, a good summary of your work, and it addresses the right audience. You can start with a draft title in the beginning, right? In the beginning, you start with the title, and then focus on writing the rest of the paper. And at the end, you can finalize the title. You can come and revise the title again. And you need to think carefully about this title because it's very important, right? Very important. And you need to use simple and concise statements when formulating your title. Use very simple and accurate statements, concise, simple and concise statements when formulating your title. So you can see it's simple and concise, this title here, on the existence and design of functional observers. It's simple and concise, right? Okay. That's the title. So this is about structuring the paper. Now, the paper need to have an abstract, right? Abstract is a short summary of around 150 words. It should be a short summary of your work in the paper. It's about 150 words, right? About. Can be a little more, can be less, doesn't matter. An abstract helps the reader whether the article is relevant to their interest and whether it needs to be read in its entirety. The abstract simply tells whether the reader should read it or not, right? It's a summary. It's a summary, a short summary. It should tell what the paper is about. So a reader will read the summary and will think whether to continue reading or not. Right? So I've given an example of an extract there, just something, right? So it says, nowadays, enabled by the current smart grid technology, electricity consumers, right, can play an active role in providing ancillary services as a type of demand response, assisting the stabilization of power grid by following the frequency regulation signal or REGD signal in the study, whilst receiving economic benefits. So that's what I was trying to explain to you before. Like customers, how they can provide these ancillary services to receive benefits. Industrial roads are an indispensable component as a demand-side regulation resource of ancillary services due to their intensive electricity consumption. It says, in this paper, we make use of grid-connected solar PV panels combined with energy storage systems to produce continuous electricity consumption signal in order to follow the REGD signal. The participation of solar energy in real-time regulation provision process is emphasized, which is modeled based on a variety of operation modes in accordance to Australian standard. So I go on to actually tell what this paper is about, right? And you want to say it in a very clear, concise manner, right? That's the abstract. Then an introduction, right? We need to think about why is your research work important? You need to state in the introduction why the research work is important. We need to state what is known about the topic. We need to tell in the introduction what is known about the topic. We need to state what are some of the gaps in understanding. So we need to tell why the research is important in the introduction. We need to tell what is already known about the topic. We need to tell what are some of the gaps in understanding, right? And we need to argue for the need for the study. We need to tell why we need to do this study. We need to tell that. We need to state the objectives. We need to tell what are our objectives in the paper, the objectives. And introduction should make the reader interested to read the rest of the paper. Right? So we need to cover these things, cover those points in the introduction. We need to argue why this study is necessary. We need to talk about what is known. We need to talk about the gaps in understanding. And we need to say this is what we are going to do, yeah, in the introduction. And we can also give outline of the paper, right? Give outline of the paper. So here is an introduction. So I probably won't read everything. In the first paragraph, you can see I have a lot of references. So I tell what is already known, right? In the first paragraph. So in the second paragraph on the bottom, we say previous studies on LFC have been based on approximating all generation tests in a given area into one single generation unit. Furthermore, the power distribution network, including transmission lines, have various bus bars as all lumped into one single entity in the analysis and design of controllers. With the growing complexity of power distribution networks, such simplified assumptions which lose the network topology may not be representative of a complex network. So I state a gap. I say the previous work may be not relevant for future power. Yeah? So you need to state a gap. Right? And then you say the analysis presented in this paper makes no such assumption and present a quasi-decentralized functional observer scheme on control, frequency, and pipeline power of a multi-area interconnected power system. So you say this paper does not. It presents something new, right? So we need to write like that. Yeah? We need to identify the work that people have done. We need to identify a gap. Then we need to say, well, we are going to solve this in this way. Right? That's the introduction. Right? So sometimes you can also, like if you're writing a theoretical paper, you can have a problem statement, right? So problem statement, the statement of the problem that addresses the question, what is the problem that this research will address? The problem statement is what is the exact problem that the research is going to address. So you can see the problem statement here. You say equation A just defines a system. I won't read the whole thing. And down the bottom it says matrices N, J, H, and E are unknown matrices of appropriate dimensions which must be determined. So we're going to find that, right? So we say, I won't go through the entire thing, but we need to say very clearly, what are we trying to do, right? We say at the bottom there it says, so those matrices are what we are trying to find. Right? So the problem statement needs to be very accurate, yeah? And it should address a gap in knowledge, right? So we need to solve a problem that addresses a gap in knowledge. And we also need to state our assumptions. If we are making any assumptions, we need to state it here in the problem statement, right? So we need to, with the methodology, if it's an experimental paper, that's another section, right? The methodology section, we need to talk about the equipment, material, methods, design of some circuits to generate data. How did you generate data? We need to talk about that. If it's a modeling paper, we need to talk about the mathematical tools, methods, include some theorems, lemmas, and proofs, may include details of some known algorithms relevant to the paper, right? If it's a modeling paper. If it's a computational paper, we need to talk about the inputs, computational tools and methods. How did we collect the data, statistical methods used, depend on the type of paper. It can be an experimental paper, modeling paper, or computational paper, right? Depending on that. That's what we will write in the methodology. We also need to talk about why did we choose these methods and techniques. What is the rationale for that? Why did we choose those particular techniques, right? And how did you use these methods for analyzing the research question or problem? So you need to state how you use those tools to solve the problem. Right? That needs to be part of the methodology. Right? And then the results and discussion, there has to be a section on results and discussion. What are your most significant results? You need to state that, right? You need to state what are your supporting results, right? Because you will have your main significant results, but you will also have some supporting results, so you need to state those. Your results should be the answer to your research question. So that should be the answer to the question you have. Your results are the answer, right? And you need to state your major findings. What is your major finding in this piece of work? Right? You need to state that in the results and discussion. And you need to state the significance and implications of your result. What is the significance and the implication of the result, right? So these are things that needs to be written, right? And conclusion just draws together the most important results and consequences, and you can list any limitations, right? And conclusions are summing up the advantages in knowledge that have emerged in this paper. What are the advantages of the new knowledge that emerged from this paper? Needs to be written in the conclusion, right? Okay, that's an example conclusion that I did. I won't go through that, right? And acknowledgements, you can thank the people who have helped you with ideas, technical assistance, materials, or finance. If your research work was supported by some grant, scholarship, then that needs to go there. You need to acknowledge in the paper, right, that support. And of course, we need to cite the previous work, cite sources of the theories, data, or anything else you have taken from elsewhere. So that's about all that I wanted to say, right? So that's about, I hope you got some idea about how to go about writing the paper. I hope you will do good research and communicate these ideas so that other people like us, we can read and learn from that. Thank you.